Good afternoon, and thanks for joining us. As you can see from our screen there, what we're going to talk about today is how we can help smooth the transition into the Esri Utility Network Model. I'm Sheila Stephenson. I'm the CEO for One Spatial, Inc., and I'm joined by Kevin Sigwart, who is our Director of Solutions. And for those of you who aren't familiar with One Spatial, One Spatial, Inc. is a U.S. company that is a wholly owned subsidiary of our parent company out of the UK, One Spatial Group, who is the developer of our One Integrate rules product. And out of the UK, we've been in existence for over 50 years and focused the entire lifetime on developing data management solutions. And hopefully by the end of this presentation, you'll get the full or the understanding of what we mean when we talk about data management solutions. But in a nutshell, you can look at the different categories that we have listed here with a variety of our clients. So it's basically focused on using our rules engine to automate the QA, QC, and validation, basically, and cleanup of data, to do automated change detection or automated completion, and also to look at not just geospatial data, but non-geospatial data. So we really can help validate the enterprise of data to ensure that your enterprise is fully in alignment. And as I mentioned, we started 50 years over in the UK. We just started over here in the US about 7 years ago with our first client, which was the US Census, but it then expanded over the last probably 3 to 4 years into numerous different types of entities, including, as you can see on the screen there, a number of utilities. We do have a number of federal clients and then some state and local clients. And you might notice that there's a number of DOTs. And the interesting thing about the DOTs as pertains to this subject is that a lot of those DOTs are migrating into the Esri Roads and Highways data model. And as you migrate into that data model, just like if you migrate into the new network utility model, the data really needs to be clean, and it needs to fit that model so that it will go in and it'll be a smooth transition. And that's what we're helping a lot of the DOTs, and now have begun helping a number of utilities with the same sort of issues and helping them prep their data to have a nice smooth transition into the new data model. And if you look at some of our global clients, we have some interesting ones, and there's one in particular that I'd like to expound upon, which is Northumbrian Water, because it's an example of the kind of the wide array of capabilities of our One Integrate rules engine. And so Northumbrian Water in 2011, very much like all the other water utilities in the UK, was faced with a problem because they managed the freshwater supplies, but they didn't manage the wastewater. And the government decided in September of 2011 that they were going to turn over the management of all of the wastewater assets over to the different water utilities throughout the country. And so as of October 1, they suddenly inherited this whole network that they knew really very little to nothing about. And so they immediately started scrambling to try to find what kind of documentation was there about the data, what kind of data existed about the network and the wastewater network, and quickly learned that they had probably at best 5% of the network documented. And so this is a real problem because obviously they wanted to provide appropriate services to the clients, and also the government was offering a stipend based on the length of pipe that the utility would be inheriting, and they had no idea what that length was. So we began working with Northumbrian. And the first thing we did was help them validate the current network and the assets that they had. And then we also looked at validating that information across, as I mentioned, their enterprise of data. And they brought in a number of different data sources. And then they brought in the subject matter experts to basically understand how would this network have been built out? What were the business rules to establish this network? And those subject matter experts on the business side, along with the geospatial experts within Northumbrian, along with the One Spatial rules authoring experts, work together to basically create a set of rules that would enable them to infer all the missing assets based on things like using the property layer, and to understand the building types and what year they were built, so they'd understand what kind of a pipe and where that pipe might be connected to the building, and all those sorts of things. So they put all of that into the rules engine, and then we're able to run that to automate the process of creating all that missing data. And they, after running that task, they then went out and did some field validations to verify. And with a 3-meter tolerance, they were finding that they were somewhere in the neighborhood of 90 to 95% accurate. And so, there was another interesting thing that came out of this, because as they were doing the enterprise validation of the spatial data to the CRM data, they discovered numerous missing accounts. And so they also gained more count base, and ultimately this project saved them a lot of effort and money. They had run an estimation that without the automation, it was going to take them to complete the entire project 15 years, and to a total of about 30 million pounds. And in turn, it actually came out that they were able to complete the project in 2 years at a total cost of only 1.25 million pounds, considerable savings. So it's a good example because, again, it involves the validation, it involves data enhancement, it involves a lot of the different capabilities that exist within our One Integrate rules engine. And to expound on those capabilities, I'm now going to turn it over to Kevin Sigwart.
Thank you, Sheila. So we originally, this presentation is about how we can help smooth the transition into the utility network data model for the Esri Utility Network data model. And what we've been finding is that unless you address the data quality issues in your data set, it is going to give you severe headaches trying to do this migration and trying to maintain a good network once you get into that data model. And some of the things that we notice that this will affect is, one, before you even think about even migrating into the network model in general, just being able to do proper analytics and tracing, if you don't have good data quality, you're not going to be able to do those. So even if you're not quite ready to move into the new network model, and you still want to be able to do some analytics against the data, making sure that the data is actually properly connected network is something that you want to address. And that's something that we at One Spatial have actually been working with numerous different clients in the utility space on that aspect alone before even thinking about this migration. Also, and Sheila mentioned this before about connecting to multiple different systems like your CRM systems and your asset management systems and your work order management systems. If you don't have proper data quality, you're not going to be able to connect into those systems. So things that we can help with is connecting to a variety of these different systems and running validation checks to see if there's any gaps or I guess any sort of gaps between these two different systems. But then once you decide that you're ready to migrate into the new network utility model, if you don't address those data quality issues, you're going to have significant performance hit inside that model. We're finding that some of the clients are having, hundreds of thousands of errors in the data set, and it will just cause the system to just slow to a crawl. So you really have to address those issues before migrating into the new utility model. And then once the data's been cleaned and you're in the utility model and it's clean enough where you're in a few hundred issues, you can start to actually work with it and leverage all that rich capability inside that new data model. And also what we've been finding is that if the data is not clean and not addressed properly, some of the triggers that are behind some of these Esri implementations don't necessarily fire off the way they're supposed to fire off. So they leave things like they call, I think in the roads and highways user community, they call it data shrapnel that gets created. So if you address these issues early on, you're not going to have these performance issues and the application triggers not firing off the way they're supposed to. So making sure that all of that is in sync is important. And at One Spatial, we can really help our clients get to that next level on making sure the data is fit for purpose. And we do that through running rules in our One Integrate product. And where we talking about data management and our One Integrate product and how it can help is in these three main aspects, and that's your data validation, your data integration, and your data enhancement. We have a rules engine where you define those business rules of your data, or you leverage existing rule sets already out there for gas utilities and electric utilities and so forth, and you run your data through this validation engine that can be that runs in a very quick manner. And you're going to see that in a few minutes when I actually do a live demo. But this is a lot better than doing it manually, because if you're doing it manually, it's very time consuming, and it's also very subjective. What's also unique about our validation engine is that we can write very specific validation rules. So we can say an asset must exist exactly in a specific location along the pipeline, whether you're using some sort of LRS, like measured values, or just using a certain length along the pipe. So you can be very specific in the geometric checks, but also leveraging the attribution. So if an asset has a specific set of attributes, it must exist on this place on the pipe, or must have this relationship to all the other pipes. The next is data integration, and I mentioned this already in the last slide, and Sheila mentioned this too, is that our rules engine is not limited to just geospatial data. We could connect to an Esri geo database or another spatial system, and then also connect to other non-spatial systems like a CRM system, and write cross-validation checks across the entire enterprise. And where this is important is that sometimes your data in your other systems may have more attribute-rich information that is not getting funneled back down to your GIS. So being able to write these cross-enterprise validation checks can really find gaps in where you're having syncing issues between your different systems. And then lastly is data enhancement. So within the rules engine, not only can we identify where there's issues occurring, we can also tell the system how to auto-correct those issues. So when you have slight issues with connectivity, we can auto-snap those features together. So auto-snap your pipelines together, smooth out the networks, making sure everything is correct, moving your service points or your meters to where they're supposed to be based off of a rich set of rules to define when something should move and how it should be moved. But beyond just doing automating the cleaning, we could create new data, like Sheila mentioned that we did for Northumbrian Water, where we were creating inferred assets. Or we can even do things like if you're bringing in a not very spatially accurate data set and you want to do some sort of positional accuracy improvement. So we're working with a lot of utility clients on realigning their network based off of a more finer resolution set of data. So validation, integration, and enhancement. So what we're going to do is we are going to run through how we can validate these data sets and how this can really help out when you're trying to migrate into the new utility network model. And the first demonstration that we're going to be doing is on gas data. And what this gas data is, this is not canned data. We have a client that sent us their gas network to run it through the validation checks. They found that they tried to take that data set and bring this gas data set into the utility model. And when they brought it in, they had so many issues that, as I said before, it slowed to a crawl. So they realized that they actually have to address these issues before they can migrate over. So they sent us the data to say, well, why don't you guys go through some of your validation checks that you have for gas utilities, show us where our issues are at so we can figure out, well, how much effort is it going to take us to clean this data set up, and then even possibly can we automate some of that process too. So some of the validation checks we're going to run through are your typical geometric type checks, making sure that pipes are a certain length, making sure there's no kinks in the network, doing attribution checks, and also doing some connectivity checks, and then also doing cross-feature relationship checks. So with that, let me flip over.
And while Kevin flips over, I did forget to mention, if anybody has any questions, feel free to enter them into the question section on the panel.
Yes, we have a lot of attendees, so we can't unmute everybody. So if you have a question, feel free just to put it in there, and I'll either address it during my presentation or I'll get to it at the end when we have during the last 10 to 15 minutes. So what you're looking at here is some gas data, and for their entire network that they are responsible for. And I'm going to just zoom in just so we can see what the data set that we're working with looks like. Now, typically when I'm doing some sort of data validation project, I get the data and I get like a map document or a pro project, and it has a certain set of symbology. And I find that looking at it with the symbology, it may be very rich and it may be very nice to look at, but when you're trying to do validation checks, it can be very difficult to see what the issue really is because the things are slightly off, symbology is offset and so forth. So what I like to do is I like to just flip it over to changing the symbology to be something a little bit easier to visualize what's causing the issue. So here we have in my network, we're going to focus on 3 data layers to start with. We have some of our gas mains, and it's symbolized by your pressure class. We have our service lines, and so they're starting at the main and going out to the service point, or the meter, I should say. And then we have our meters. So some of the validation checks we're going to run are we're going to check the attribution, making sure that it has the proper attribution. We're going to make sure that there's proper connectivity, so making sure pipes are connected, making sure we're going to look at the way that the connectivity is set up. So not only are we going to validate that a meter is connected to a service point, but it's connected to the end of the service point. And in this case here, we can see that the meter is connected to the end of the service point, but over here, it's actually connected to the beginning of the service point. So this is going to be one of the issues that's going to be flagged when we run it through our validation checks. So with that, let me flip over to our validation engine. So this is our One Integrate product. It is the way that we can write business rules to validate the data and automate the process of cleaning it. Right now, we are in what we call our Sessions tab. This is how we set up what data sources we're going to connect to, which rules we're going to run to validate the data, how we're going to report out. So are we going to pinpoint on the map where the issues are occurring, or are we going to auto correct the data? So we can run that all in our Sessions tab. And the Sessions tab is made up of a data store. The data store is how we set up the connections to the environment. So if I just select over here my data item, we can see here we're connecting to a file geodatabase, but we're not limited to just one set of data sources. We can connect to a variety of different data sources. In this case, it's the file geodatabase, but if your data is in some sort of enterprise geodatabase leveraging SDE, we could connect to an Esri geodatabase, and that also supports different versioning too. So if you have your Esri geodatabase versioning, we could connect to that version and just commit those changes to that version itself. But it's not limited just to Esri databases. We support a wide range of formats, as you can see in this list, but this can also be extended to connect to a variety of other sources beyond just in this drop-down list that we have here. But some of the ones that I really want to highlight are if you have spatial data that's in the native spatial format in SQL Server, Oracle, or Postgres, we support that. Or even if you have non-spatial data in these 3 different databases, we can also connect to that. So that's how we can do these cross-database validation checks. We also support connecting to CAD drawings. So if you have Autodesk CAD drawings or Bentley, we can connect to those also. So once we are bringing in that geodatabase, we import the schema. So this is how we can write rules against the data set. We know which feature classes we have access to and which fields we also have access to in writing rules. And these can also be configured. So if you need to do some sort of schema mapping, maybe you're sharing rules between different organizations and they are representing the data slightly differently, you can update these so that you only need one set of rules. So the rules are when you are identifying what the data must conform to. And then we have actions, which are how you identify what to do if a particular data set fails a particular rule. Do you want to report out a point, notifying where it's at, or do you want to correct that data set? And I should also mention that these are all configurable. And I'll get into the rule authoring process a little bit later in the demonstration, but it's a configurable interface for authoring rules. So let's go back over here to my Sessions tab. And I'm going to go ahead and fire this off. And what we're going to do is we are going to connect to that entire utility network, and we're going to focus on these three layers: the distribution main, the meter, and the service. So somewhere around the order of, well, exactly 86,000 some features that we're going to validate, and we're going to validate that across 28 validation checks. And I'm going to go through some of these validation checks that we're performing right now. So we're doing the essential geometry checks. Those check for typical geometric issues that we find in most geospatial data sets, and we provide that as an out-of-the-box set of rules. So you can just start with these set of rules when you're doing some validation checks, and these are for all of our clients that are GIS-based clients. And some of the validation checks that we perform in this is things like duplicate vertices, kickback, spikes, so those are kinks in the network, multi-part geometries, looking for containment features, looking for duplicate features, so two features with the same geometry. And when we run a validation check, like the kickback check here, we are giving a report on what our conformance ratio is. So of the 86,000 features in the data set, 138 of them have a kickback inside of them, which gives us a conformance ratio of 99.84%. So we're seeing what that conformance is. We also have the ability to take that and write that out to a result, which I will show you shortly. So after we do the essential geometry checks, the next set of checks are more specific to gas data. So we have rule packs within different industries, and we have a whole set of gas validation rules that we've written out already. And some of the validation rules we're looking at here is we're validating that the attributes are attributed correctly. So the status field is populated, and it's populated with the correct information or the correct values. We're also looking at the legacy ID and making sure that if a pipe has a legacy ID, there's no other pipe with that same legacy ID. So making sure we don't have duplicate legacy IDs. Validating that the material and the diameter is populated, making sure we don't have any self-intersecting features. So doing geometric checks. We're also validating the length of a pipe, making sure we don't have any pipes that are isolated. So a pipe must be connected to another pipe. But then we can also look at the attribution too and saying not only is it connected to another pipe, but it must be connected to a pipe within the same pressure zone. So looking at the low and high pressure zones. And here we have making sure that we don't have overshoots or undershoots. So looking at that proper connectivity. And then lastly, we're going to do some integration checks. So we're going to make sure that my services are connected to the pipes or the mains. We're going to make sure that I don't have any orphan meters. And we're going to say that even if a meter is connected to a service line, we're going to say that it must be connected to the end of the service line. So what you just saw here is we just ran those 86,000 features through 28 validation checks. And so we did somewhere around 2 million plus validations in under 2 minutes. And that's one of the real powers of our One Integrated software, is that we take the data and we import it or bring it in to our object-oriented disk cache that's designed to be able to handle these quick feature-to-feature transactions. It indexes all the features in the attribution, and then it performs extremely well, and it also scales out. So this is why when you saw that slide that Sheila was showing about some of our clients, they're typically clients that are dealing with very large data sets like national governments, or they're dealing with very complex data sets like transportation and utility clients, where they need to be able to validate large networks and miles of pipeline against several assets, and they need to be able to do it in a very performant way. So now that we finished running those validation checks, we had the option to write out those results to a database table, and I have done that already. So let's go ahead and take a look at what these results look like. So I'm going to go ahead and let's zoom back out to the full extent. So when we ran these validations or this data through the validation engine, we found quite a bit of issues. And this is one of the reasons why they had such issues with migrating into the utility network model, is that they had significant issues in their network, and they have to address these issues. So let's take a look at some of these results. So over here, we're flagging that we have a duplicate feature. So I'm going to go ahead and select this feature. And in my feature here, we're reporting that there is a duplicate feature. And what we'll notice here is that we're reporting out which data set this occurred on, what was the ID of the data set, and what type of error is occurring. But this is all configurable, so we can actually add additional fields. We can write out whatever information we want to write out that is going to help a user address these particular issues. Maybe we want to say not only is it a duplicate feature, but it's a duplicate feature that is that has a duplicate of this feature ID, so you can add that additional information to it. Here we're flagging where we have a duplicate vertice or duplicate vertex. And if we look at my particular data set here, we could see that there are 2 duplicate vertices right here, and there's 2 duplicate vertices over here. And this typically actually occurs when you're really importing data into your network model. Esri's gotten really good about being able to handle these types of issues when you're doing the editing, so you don't typically introduce these issues anymore using the Esri editing tools. But if you're going to import data, like you're importing data from a CAD-based system, you may actually see a lot of these issues. So sometimes when we're working with clients, we actually are validating the data before it comes in. So we set up about the validation engine to validate their CAD drawings to make sure their CAD drawings are ready to be integrated inside their GIS. So that's something else that we can also help utility clients on, and not only validating the data, but also helping with integrating it and making sure you maintain your topological network. Here's where we're identifying that we have a spike. Notice how we're actually pinpointing exactly the vertice that is causing the spike. And this is different than a lot of other validations. A lot of other validation systems will just tell you that there's an issue with a feature, but it won't tell you where that issue is occurring. And if you have a pipeline that is several miles long and you have a spike that is only a meter or so long, and you had to go through and pan and zoom through the map to identify where that issue is occurring, it could take you an extremely large amount of time to try to find that. So being able to pinpoint exactly where that issue is occurring is really helping the editors clean the data up in a lot quicker manner. And I have a couple other examples of spikes. Here's another example of a spike. This typically occurs when somebody's digitizing and instead of hitting F2 when they finish their edits, they are double clicking with their mouse and then they slightly move their mouse a little bit and it creates these like kinks in the network. And then here's just one more example. And this may have been they're trying to get it to connect over here and they created another point and it created this, this kink in the network. Then we have containment. So if I select over here, I have 2 features. Now this is gonna be very hard for you guys to see over the webcast, but one of the features extends all the way down through here, and the other one, if you can see it flicker on the map, it ends right about there. So it is fully contained inside this other feature. Where we have an undershoot, so here we're identifying that we have an undershoot. This is another thing that's going to be very difficult for you guys to see over the webcast. And also because ArcGIS Pro only lets me zoom into a 1-to-1. ArcMap will let me zoom in a little bit further. But in this case, there's a little bit of a gap between these two, and we're flagging that. Now, to the naked eye, you will never be able to see this, but if you were trying to do any sort of network routing or any sort of modeling, it would not go through here. So this is why it's important to validate to make sure that your network is correct and do it in using some sort of validation process. Here we have another undershoot. In this case, we're flagging 2 issues. We're flagging that there's an undershoot, but we're also flagging that we have an isolated pipe. Because what we'll notice here is that not only is it not connected, but it's not connected to any other feature. So we're flagging both that it's disconnected and it's isolated. Here we have a pressure mismatch. So basically we have one pipeline coming into another where the pressure gauges are changing. Now, in this case here, we probably would want to have, there's probably some sort of valve located at this location. So we can update the rule, we can reconfigure the rule to say, it's okay to have 2 pipelines connected that when the pressure changes, as long as there's a valve located in that location. So we can update these rules to be more specific to include other data items. And then here we have a isolated pipe by pressure. So because even though this pipeline is connected to these other pipes, because there's a pressure change, it's an isolated pipe. So doing that cross attribution and geometric relationship. We're also validating that we don't have any orphan meters. And we have our meters here that are not connected to service lines. So we're flagging those as non-conformances. We're saying that my meter must be connected to the end of the service line. In this case, it's connected to the beginning of the service line. So this service line is actually digitized backwards. And then we are saying that the service line must be actually connected to the pipeline, the main. And what we're finding here is the service line is actually split into two separate service lines. So that's why we're flagging that as a non-conformance. In this case, there might be an asset that's located here. So we would just have to check to see if there's an asset located in this particular location. And then the last use case, this is something that we were doing for actually a water utility client. And they wanted to identify where they had features that were crossing over their pipelines that were not split at the pipeline. And what they found was that we found issues where we had, in this case, where we had the pipeline, the service line crossing over, but then we also found where we had these jumps located in the network. And what this jump is saying, and I'm sure everyone on this call knows this already, but it's saying that actually the pipeline is not actually connected. So it's jumping over this particular location. So what this client wanted to do is they wanted to identify not only when there were crossing over, but when they were crossing over and it wasn't a jump. So what we were able to do was identify which ones are crossing over and what type of crossing it is so they can just filter down and focus on the ones that are crossing over that do not have a jump. So as you can imagine, if you're trying, if you are this utility client and you are trying to address all of these issues and you're seeing that I have a lot of work to do in order to get into the utility network model, you may start pulling out your hair and saying, well, how are we going to actually get this done in an efficient manner? And this is where we can automate some of that process of automating some of the cleanup in order to address most of the issues, to really get it down to a reasonable amount of effort to manually correct those last few items. So what we're going to do is we're going to flip back over to my One Integrate product, and now I'm going to run some fix-up actions or some cleanup actions to address those issues. So let's fire this off. So the first set of fix-ups we're going to do are our essential geometric fix-ups. So just like we had the essential geometry checks, we have essential geometry fix-ups. And this enables users to be able to not automate that process of updating those particular geometric issues. So things like we're going to remove duplicate mains, remove our duplicate service pipes. We're going to get rid of those extra vertices, those duplicate vertices. We are going to smooth out those spikes and kickbacks. And then after we run those fix-ups, we can also recheck to see if we have any existing issues. Now this, I'm just showing you this really to just kind of give you an idea of where we're going, where we were at and where we got to. But in some cases, you may want to run the fix-ups and then run a report out on where the issues are occurring so that you can go back and address only those issues that are left. So for example, if we're looking at my kickbacks, I have 86,000 features and I'm now down to 2 non-conformances. And if you remember before, we were at somewhere around 168 non-conformances. So we were able to solve about 158 of them right off the bat. So the next thing we're going to do is after we run those essential geometry cleanups, we're going to do what we call build topology. And this helps us, we can enable snapping our features together when we're building our topology. And what we do is we set a tolerance. So in this case, I'm setting a 0.1 tolerance. And I'm going to say that if there's a service point that's within 0.1 meters of a meter, snap that service line to the meter. And I'm going to say if there's a meter or a service line within 0.1 meters of a distribution main, automatically snap those together. So it's just going to update the topological network based off this tolerance. And you could set this tolerance to whatever you're comfortable with the scale at which your data was digitized, so that you're not going to introduce any sort of issue with updating that. Now, if you don't want to automate that process of snapping things together and you want to have it more of a rule-based approach where you're being more judicious with how you're doing the snapping, you can also set that up too, so that you're being more specific. So after we build the topology, we're going to do a few more other fix-ups. The other fix-up we're going to do is we're going to flip the digitized direction. So we're going to say if a service point or service line is connected to the start of a meter, but not connected to the end of the meter, let's just flip that digitized direction. So just reverse the digitized direction. The next thing we're going to do is we're going to move my meters to connect to my service lines if there's no other meter that's within a certain tolerance of that service line and the service line doesn't already have a meter connected to it. I got ahead of myself a little bit. And then after we do that, we're going to run those last two validation checks. So while this is continuing to run, let's just go back here real quick and just see. So we did that duplicate feature check. So notice here we have 6 duplicate features, and where we were at originally with my duplicate feature check, let's see if we come back up here, I had about 68 duplicate features. And the reason we still have 6 left is that I didn't remove the duplicate service points. I wanted to keep those, so I only removed the duplicate mains and the duplicate service lines. All right, and then now we're going back and we're checking where how many orphan meters we have left and how many meters are not connected to the service line. And for the sake of time, I'm just going to flip over and show you what we did here. So let's go zoom to some of those example issues and see how we automated the cleanup of the data. So I'm going to go now turn on my cleanup. Now, when we're doing this cleanup, we have a couple options. We can create a new data set of the clean network, or we can update your existing SDE data set. So if it's in some sort of enterprise geodatabase or enterprise database, we could commit those changes to a specific version so that you can leverage the Esri versioning technology to review those fix-ups before pushing those back up or committing those changes back up the chain of the versioning tree. So if we look over here at this particular service line, we can see that now there's only one service, so we remove that duplicate service line. Now, these rules are also configurable, so maybe instead of just removing it if it's a duplicate geometry, you want to look at the attribution too to determine which feature to keep. You can also do that also in the rules engine. Where we had that duplicate vertice, if I select my feature now and take a look, we remove those duplicate vertices, so we don't have those in the item anymore. Where we had those spikes, notice that spike is gone. It's kind of hard to notice it because we don't see it anymore, but there's where the spike was originally. Well, let me turn my markup so I can actually see where the spike was. As I said, it's hard to see these things without having these markups. So you can see how we fixed this spike. It's no longer there. Now here's another example of where we cleaned up the spike, and now, and we also, don't forget, we're also maintaining the topology, so we're not breaking the topology when we're doing these fix-ups. And then here's another example of where we cleaned up that spike and we have the proper connectivity. Where we had that undershoot, it's now connected at both ends. Same thing in this case, we had that undershoot and that isolated pipe. Now it's actually connected. Where we had orphan meters. Now what we'll notice here is that this particular meter that was originally right here, we moved it because it was within the tolerance that we set up, and there were no other meters to conflict with this moving this particular meter. We'll notice that these 3 meters over here, we did not move over because there was already a meter that was connected to the service line, and there was also another meter within a certain tolerance of it. So because of both of those were failing, we're not going to move this meter over here to this particular location. In this case, this is where we reverse the digitized direction. So it was originally digitized this way, and now it's being digitized this way. Oh, I'm sorry, I flipped it. It's now being digitized the correct way, which is this way. And that was the and that's all the fix-ups we did. So let's go back real quick to One Integrate. Now, I mentioned I would talk about how we can write and author rules. And when I say write and author rules, I mean configure rules, because this is a configurable interface. You're not doing any sort of hard coding or anything like that. You are configuring the rules themselves. So if we flip over to my rules tab, here's an example of one of the rules that was written. We can choose which data set we want to validate against. So in this case, I'm validating it against my distribution main. We can choose which attribute we want to validate against. In this case, I'm validating against the facility status. And I'm saying my facility status must not be equal to null. But as I said, this is fully configurable. We can change which attribute we want to validate against, or what type of validation we want to do. We can make it more complex and do multiple validations. So for example, instead of saying it's not equal to null, maybe we want to say the facility status must equal a set of values. So we could say it must be equal to active, PR, IC, or IA. So we could be very specific in the way that we're validating that particular item. We can make sure that we have a unique legacy ID. So we're making sure that, well, first we're saying if the legacy ID is not equal to null, there's no other feature where the legacy IDs are the same. And then we can get to more complex validation checks. So for example, we're saying that a meter must be connected to exactly one service line. So we're saying that they intersect the service lines, but maybe we want to be more specific, and we want to say not only should they intersect a service line, but it should intersect the end of the service line. So we can say for every service, there's at least one meter that intersects it, but it intersects it at the end of the line segment. And we can do this what we call built-in functions. So we could take a geometry and get the start or the end of that geometry, or do a whole host of different built-in functions. So get the end of, we can get the start of. We can do other types of geometric functions, find any geometry within a certain tolerance, so using buffers, a whole host of geometric functions that we have. We have conversion functions, so if you need to convert something from a string to an integer or what have you, mathematical functions. String functions, so if you're trying to do string comparisons, you can use the Jarrow-Winkler similarity model or the Levenshtein distance model. This can be very useful, especially if you're trying to look at accounts, like duplicate accounts, and looking at address information, using this to see if there's street names that seem like they're duplicates, but maybe they're not exact, the strings aren't exact matches. And then lastly, what we find in the utility space, which is very useful, is using measured functions. So if you want to say a particular asset must exist at a specific location along the network using LRS, we can use our LRS functions to do that. And then one other quick validation check I want to highlight is where we're not just looking at a geometric check, but we're also pulling in the attribution too. So this is where we're looking at isolated pipes that's specific by the standard operating pressure. So we're saying that if when the geometries intersect, they must also have the same standard operating pressure. So leveraging attribution and geometric checks. All right, I'm also realizing that I'm getting close to being out of time. All right, so the last set of the last example we have is we're not just saying we have rule sets for a variety of utility clients, not just gas utilities. So these rules can be configured and written for also electric utilities. So this is just an example of some of the same client actually gave us not just gas data, but they also gave us electric data, and they had us validate their electrical network. And instead of opening up and showing you running the rules, I'm just going to show you what some of the validation checks that we ran and what the results were inside the data set. So let's flip over to my electrical utility network. Now, typically electric utilities can be a little more complex. We have overhead, underground conductors. We have lots of different assets that are associated to these particular networks. And we have rules that we've configured to do some of these validation checks. So just like you have with gas lines, you also have it with electric utilities. We have the same thing where we have spikes and overshoots and undershoots and kickbacks. So those essential geometry checks can really help out with identifying those issues. Duplicate features. So here we have duplicate street lights. We can look at, if we have a transformer, we can say the transformer must match the conductor's feeder ID. So in this case here, we have a feeder ID that's null. We can also check to say that if the fuse bank is open, if the status is open, so let's come down here real quick. If the normal position is open, then the feeder ID 2 must be populated. And notice here, feeder ID 2 is not populated, so we're flagging that as a null. Orphan devices, same thing, we have orphan devices. Feeder ID mismatch, so here we have a feeder ID, we have my meter. In this case, we have actually 2 meters. One of the meters has proper attribution and the other one doesn't. So this one here, the feeder ID is not populated. So it is a mismatch between that and the conductor. Making sure that my meter is connected at the end. So this is one of those cases where if you were running a, some of these out of the box validation checks that other validation software has, it will tell you that yes, this meter is connected to this network because it's intersecting the network, but it's not intersecting the network at the end of the location. So because it's not intersecting here, we're flagging that as a nonconformance. And let's see here. And the last one I want to show is looking at poles for overhead conductors. So we're saying that for an overhead conductor, if there is if you have an overhead conductor at every single segment, there must be a pole. And what we have here is we have a conductor that's shifting directions and no pole located at this location. So how is this conductor existing without a pole, and how is it shifting directions? So either this needs to be merged together or it should have a pole in this particular location. So we were able to leverage the One Integrate product to validate the networks to identify where there's issues with the network. And why that's important is that we need to be able to clean this network up before going into the new Esri Utility Network Model. And by cleaning your data up and getting it in there, you're going to really save a lot of time and effort in that process. So with that, I'm happy to answer any questions that anybody has.
Yeah, so we have just a few, Kevin. Okay. And 2 of them are kind of similar, so I'll group them together. One was, is there a limit to the number, or is there a limit to the quantity of the data that you can run the rules against? And then another one was, do you have to break the data into manageable chunks to run the rules successfully?
Oh, that's both great questions. So there is no limit to the amount of data that you can push into the One Integrate product. The One Integrate product operates on a disk-based system. So as long as you have enough disk space to pull the data in, you can validate extremely large data sets. Some examples are, we validate NOAA's electronic nautical charts. These are millions and millions and millions of records. Close to 100 million records that we validated inside of the One Integrate product, bringing in their entire electronic nautical charts, validating it, doing very complex validation checks, and doing it in a very performant way. No, there is no limit. Now, if you want to, you can process chunks together if you need to get the data ready in 30 minutes and you need to process 1 million records, there is the ability, the engine itself has the ability to process segments and then bring it all together. But typically the performance of the system, most clients don't need to worry about that.
And then the next one was, is there a limit to the number of rules that can be run?
No. So you can run as many rules as you want. The more rules you have, the longer it might take, but it's not like there's any limit. So I'm trying to think of some examples. In some cases, we've written hundreds of rules for different clients, and it just runs through all those rules. What we do find, though, is that, and I kind of didn't really, and Sheila, this is actually a good point that I forgot to bring up in my presentation, is that our rules engine, when we write rules, we write them in a positive form. So you define what the data must conform to. You don't write what the data must not be. And because you're writing it in a positive form, you actually find that you actually need less rules than in the reverse. And not only that, sometimes when you write rules in a positive form, you find issues that you would never have found if you were just trying to find those particular, if you were trying to write queries to find issues that you were expecting to find.
Exactly. I always like to say you don't know what you don't know.
Exactly.
So the next question was, is there any way that the rules engine can be used to improve location accuracy of the network data?
Oh, okay. Yeah, that's a great question. So, and I kind of mentioned this way in the beginning, but I kind of breezed through it real quickly. And so let me try to take a minute to explain what I meant by that. So we have this concept in the One Integrated Engine called positional accuracy improvement. And what we find is that a lot of utility clients are, they're getting more accurate data sets, such as they may get a new updated parcel data set that is more of a survey grade data set. And their old network was built off of this old parcel data set. And what they want to be able to do is shift their network to align to this new parcel data set. So in the rules engine, we can define what the relationship is between the old parcel data set and the new parcel data set, automate the process of building what we call shift vectors, and then shift or rubber sheet the data set to match those shift vectors. But while we're doing that, we're doing it in the rules engine, so we can make sure that we clean up any sort of conflicting vectors that get created, and also making sure that we maintain the topology as we're doing that shifting. So we're finding a lot of utility clients in the US and throughout the world are interested in doing that, and we're helping them with those efforts.
And the next question was, can data in different systems be validated against each other?
Yes, and we didn't really get into that in this case, but because the way that we operate, that we pull the data into this engine, and I should also mention that this engine is a product. It's not a SaaS-based system. While it can be deployed in the cloud, most of our clients are deploying it on site and on premises at their location. Make sure to get that clear that up. But it sucks the data into the cache, and then you could pull data from another data source. So you can pull your data from your GIS and pull data from your other system, your non-spatial system or whatever system.
Like a CRM system. Or
exactly. And then you can write a rule saying that if this asset exists or if this service point exists inside of my GIS system, there better be a record in my CRM system. I better be billing that client, that customer for their services.
Exactly. And we've just got a couple more. The one is, can it help with CAD and GIS integration?
And yes, so another area that we're finding a lot of interest in is helping with the CAD to GIS integration. So we find that clients that are trying to push CAD into GIS, it can be a very manual process. But within the rules engine, we can actually define business rules for how to integrate those data sources. So if even if your data doesn't have geospatial information inside of it, if it's not georeferenced, there may be information inside the drawing itself that can be used to help shift and align it into the GIS. But before you get to that piece, you also, and like I mentioned earlier in the presentation, you want to make sure you validate those CAD drawings first, clean those CAD drawings, and you can do all that inside the One Integrated product, just like you did with the GIS data, and then write business rules for how to integrate it. So really automating that process.
Okay, and last question. This is kind of specific. Can it validate SAP data?
Yeah, so if, well, there's two aspects to this. One is In the old SAP systems, they were built off of, the background database was Oracle, so you could connect to that Oracle database and do those validation checks. But we have worked with SAP to integrate directly into SAP HANA. So if that's something if that is something you are interested in, we can have that conversation dive a little bit deeper into that use case.
Perfect. Well, that's all the questions that we've received so far, but on this slide, we've got our emails up there, our contact info. So please feel free to reach out if you have any further questions, or if you have a desire to dig deeper, as Kevin said, into any one of the subject areas that we presented today.
All right, thank you very much.
Thanks, everybody.